In this video, we are talking about the analysis of an existing road, which is about 900 meters, and it has 40 millimeters dense graded asphalt surface. And it's two-lane highway with an unsealed shoulder located in a rural environment with a base course of 125 mil and subbase 125 mil again, as you can see in the section. The subgrade is silty sand with a CBR of 5%. According to the visual inspection, the rotting, crocodile cracking, and pumping were observed. The maximum pavement surface deflection measured by running the FWD, which is the falling weight deflectometer on site, every 20 meters. These data needs to be adjusted by the factor of temperature and seasonal moisture correction. The temperature at the time of the test at site was 30 degrees, and also WMAPT, which is weighted mean annual pavement temperature, also 30. So that factor would be 1, and it doesn't affect our data. The seasonal moisture correction factor is also reported as 1, so we don't need to adjust that data. Now we should standardize the measured values, which can we find that factor from the table, and it depends on the thickness of the current asphalt. This factor here is 1.14 according to the table from Ostroge part 5. All the data multiplied by 1.14, and next thing we need to do is find the homogeneous sections, which we call it lot. We have 4 lots. It is important to find the lots or homogeneous subsections properly, as for selection of the lots, the result would be excessive overlay or vice versa. Road recommended that the subsection should exceed 100 meters in length and should be considered homogeneous if the deflection values have a coefficient of variation of 0.25 or less. If it is more than that, then the subsection may need to be further subdivided. The design of flexible overlays on flexible pavements, a characteristic deflection is assigned to each subsection for evaluation purposes. These values are determined after the seasonal and standardization adjustment have been made to the individual test measurements. As you can see, we bring all the data in this table, and we call this table data summary table. So in the column 2 and 3, we bring out the data from the site, the maximum deflection, and to make sure the CV coefficient of variation is not more than 0.25. Then the characteristic deflection for each lot is calculated, and we understand we have on lots 2 and lot 4, the CD is more than the design deflection. The characteristic deflection is equal to the average deflection plus a factor F times the standard deviation SD. For the design of granular overlays and granular pavement, the principal criterion is the limitation of permanent deformation on the pavement surface. The design deflection for our traffic load is 0.95 millimeters. As you can see, on lot 2 and lot 4, CD is over greater than our design deflection, which means we need to design overlay. The Ostrode has the graph which we can find the thickness of the granular overlay. So we go and check in according to the characteristic deflection before overlay, which in our case is 1.66. But you can see for the granular overlay it doesn't really work. So we need to go and check the asphalt. So for asphalt overlay, from the graph we can see we need 80 millimeters. But this graph belong to the deformation at WMAPT of 25 degree. So we need to adjust this with another factor, which will be read from figure 6.10 from Ostrode's part 5. So it depends on the binders. This factor will be different. So here, the overlay thickness would be 1.1 multiplied by 80 mil, then we get 88 millimeters. So we round this up to 90 millimeters. Don't forget is to check the required thickness, which will affect the CBR's value and the design traffic value. The required thickness we get here is 470 millimeters. By subtracting the sub-base and base thickness from this thickness, the required thickness, we get 95 millimeters for the overlay thickness of the asphalt. Here is completely preliminary. We need more investigation and more tests on site. For example, we need to know exactly where these rotting and crocodile cracking and pumping it's happened. We need to also see the digital terrain model and to find out where our section is located in the cut area or fill area, or is it really the problem is a drainage problem, or is it the strength of the pavement? We also need the 4-day soaked CBR from the change 440 to 827. This is where we get the most maximum deflection, which is the CD is more than our deflection design. So maybe we can suggest that to extend the pavement over the shoulder and also improve the drainage in this area. Also, we need to get the atmospheric limits to check what's the material we got on site and what sort of pavement we have. The conclusion with study with the existing data from the FWD test, we really suspicious in the drainage problem, which mostly occurring from the drainage 440 up to end of the road 827. We need to remove the existing asphalt layer because there was the pumping in this area and the crocodile and rotting, which means the ingress of water through the pavement surfacing. More valuable data, including for example, where is our services? And if the existing services is lower than our pavement, then we can dig out the existing and overlay with the new design, and which is we need at the moment with the new traffic load 470 mil of pavement. I hope you enjoyed this video. Thank you. Bye.